Hi, good morning, welcome to the Madstar Observatory. Guys, I wanted to talk about the muon, and don't worry, we're not going to get too deep into particle physics, we're not going to go that far into it. I'm going to keep it nice and easy so that you can understand it. But I thought it'd be a good place to start this video, just briefly talking about the muon and a little bit about it, and then we're going to use our imagination a little bit later on in the video, and we're going to go off and talk about something completely different, and I think you'll enjoy it. So stick with us. Before we do, big thank you for everyone supporting us. It's amazing, guys. You know, without you, we wouldn't be doing what we're doing right now, and that is in the process of building our muon detectors. So a little bit about the muon. It shouldn't exist at ground level. If you do the math, the particle is itself travelling at the speed of light. It's got a very short life and it burns itself out very quickly and disappears. And at 10 kilometers, when it comes through our atmosphere, or a cosmic ray comes through and enters our atmosphere, it will strike another particle, and as you can see from the diagram, a pion is created, a neutrino is created, and a muon is created. Now, the reason why it shouldn't exist at ground level is because of its lifespan is only a couple of milliseconds, and if you do the math, 10 kilometers divided by the time, 2 milliseconds, it should have burned out long before it reaches the surface of the Earth. And this is where we go into relativity, and what's happening with the muon is it's behaving in its own time frame, so it's cheating time, and that's allowing it to get to the surface of the Earth where we can detect it. So it shouldn't exist at the Earth. If you've got 1 million muons at 10 kilometers, by the time they reach the Earth, only about 0.3 of them are on the Earth, and I believe that Spence at MIT has detected on average around about 3 or 4 every few seconds or every minute or something like that. But we'll find out anyway. Once we build our muon detectors, we'll know what the rate is over a minute, and we can times that by, you know, if we get 1 muon in a minute, we can say that originally, because we know how many exist at 10 kilometers, we can say that that represents, you know, 0.3 million at that altitude, or 3 million at that altitude. What's the point in all this? I'll show you guys. Well, the point is very simple. As you can see from this picture, there is like a muon shower or a cosmic shower happening, and that's because of how many collisions these particles are hitting each other and smashing up each other. If we just think about what happened on Mars, perhaps when the magnetosphere weakened, it was left subject to the cosmic radiation at some point in its history, which allowed it to strip off perhaps most of its atmosphere. When the atmosphere was gone, it then probably eroded all the water on the planet in a similar fashion. It may have evaporated off, as it never had no protection, and as a result left it looking the way it did today, or does today. We know through its study of terraform on Mars that we can see that water must have been flowing on there for thousands of years for it to erode riverbeds like we see when we look at detailed pictures of Mars's terraformal surface. So, you know, it poses the question, you know, if we keep having a bombardment of cosmic radiation as a result of a low solar output or a grand solar minimum, then, you know, our atmosphere is at risk, and it will be at even greater risk if our Earth goes through the next magnetic reversal and as a result erodes our atmosphere. You know, we will know straight away, according to the Polar missions, when they was travelling to the moon, they left the protection of Earth's Van belt, and, you know, whilst they was outside that region, the astronauts themselves was experiencing cosmic ray strikes through, I believe, a part of the retina in their eye, and it was causing white light strikes. So if we were subject to a lot of radiation in that same you know, scenario, then we should experience the exact same thing here on Earth's surface. When lots of cosmic rays go through our retinas, you should see like white strikes in your vision. As you know, we can do a couple of things about it. We can reduce the risks like those astronauts did on that journey to the moon. We can take antioxidants which slow the cellular reproduction down, giving the cell time to repair itself and rebuild that DNA. And as a result of that, it might prolong or protect us a little bit from the effects of cosmic radiation causing cancer. I don't think antioxidants would have the same effect on cardiac arrhythmias, but that is again something that we're going to be looking at a lot more detail a bit further down the road. What we want to do is just take a few samples from around the world with our muon detectors and find out what regions are experiencing more cosmic radiation, and then start going to the medical side of things and asking the question, at what levels are safe and at what levels become harmful to humans. We know that some people work in certain environments where they're considered to be at an increased risk of radiation. They've got a term for it, but I can't think of it at the moment. But the point is that like jobs, if you're a pilot, you're going to be subject to more radiation because you're at 40,000 feet, and we've seen on a chart the increase in radiation at that level. So we know that by the time it gets to the Earth, we've been protected a little bit more, but we might be protected, but the thing is here is our atmosphere is not being protected, and that might be good for us, that these particles strike all the other particles and leave almost inert and harmless particles at surface level, or at least the amounts at surface level. But that doesn't mean that our atmosphere is not getting eroded away by cosmic radiation coming through our heliosphere, which should be plumped up nice during a good healthy solar cycle where there's plenty of solar activity inflating the heliosphere. If it should go into a low solar cycle like we're in at right now, the radiation kicks in tenfold, and right now we're in the trough of solar cycle 24, and we couldn't be in a worse situation. Let me just show you what happened at the trough of solar cycle 23. So as you can see, at the trough of solar cycle 23, when all the sunspots start to die off and it goes into a trough, the radiation increases. What's happening here at this point, when the sun's going into its low period or the trough in the cycle, is the heliosphere is shrinking, and as it does that, the radiation is allowed to come through our solar system a lot more, and as a result it comes through our atmosphere a lot more, strips off and smashes its way through lots of other particles, and then out of a million, 0.3 muons will hit the floor, and that will give us an indication that there has been a lot more activity higher up in the atmosphere, around about 10 kilometers. So we can monitor reasonably accurately how much radiation is coming through at whereabouts on our planet. I just want to, before I end this topic and then talk about, we'll go off on our little tangent, but before I do, I just want to show you where the weak spots are right now. Low magnetic intensity and low protection on our planet, and it'll be really interesting if we can get our muon detectors in these regions to see at what levels, and if they are at dangerous levels, what the amounts are in them regions. So we've got regions of our planet that are in blue, which shows the lowest magnetic intensity. This one in particular, the darkest blue, is over the South Atlantic. It's actually classified as the South Atlantic anomaly, and it's very low in actual magnetic intensity. You can see the redder areas, and the darker the red they go, the higher intensity is. Now, I believe when we put our magnetometers in the core of these red spots, we'll have less cosmic radiation in there because there is still a high intensity in that region, and I believe that the magnetosphere is working its best in them regions. However, it is going to be very interesting if we can get a muon detector in Brazil or South Africa and just take some readings there and see what the radiation levels are in those regions, because these are the regions on our planet that have possibly the least protection from muons and other cosmic rays that are inbound in our atmosphere. So I'm going to leave it here. I just wanted to, tell you a little bit of the story behind the muon and how it works, and the fact that it operates in its own time field, which is a little bit hard to get around your head round. But basically, the muon is a time-traveling particle, and it shouldn't exist at the ground surface. If you do the equation, the math, 10 kilometers divided by the speed of light gives you how long the particle needs to get to the floor, and when you work it out that there's only 2 milliseconds of life expectancy from a muon, you know that it shouldn't even get halfway down before it dissipates. or burns itself completely out. So we've got a time traveling particle. It also proves that time travel is possible. Yes guys, time does actually alter with the amount of speed, and we proved this back in the 60s. There was an experiment conducted with 2 atomic clocks, very accurately calibrated at the very exact speed, at the same time. One of these atomic clocks was put on a plane, and I think it flew for a duration of about 5 or 6 hours. When the 2 atomic clocks was put back together side by side, one had slightly advanced, indicating that speed does in fact have an impact on time as it's moving by. So we've got 2 experiments that show, first of all, the muon reaching the Earth's surface tells us that it's doing something else, so it's relativity, in that field of relativity. And we've also got the fact that when we put these 2 things, one on a plane, one on the ground, brought them back together, again reiterated the fact that time travel is exactly possible. Now guys, we're going to use our imaginations a little bit, like I mentioned in the beginning of the video, because about a couple of weeks ago, and I read every comment in the section, someone said to me, I like what you talk about and all the other things that you do on the channel. You said, but your idea with the laser communicator I think is a bit of a waste of time. I don't think it is. And you know what guys, how do you know we haven't already been successful? And what do I mean by that? Okay, so if we are going to build the laser communicator at a later date in the future, and we're going to send out a message, then we might be lucky to send that message to somebody that can actually read it. Remember, we're going to pulsate a high-powered laser, and we're going to fire the laser out into space. So the message will travel beyond our solar system and further. So if we're pulsating this message or messages regularly, what's to say an advanced civilization, more advanced than us, much more advanced than us, hasn't already intercepted that message, worked out where it came from, and travelled at a greater speed to come back to this planet and find out a little bit more about the species and the message itself. Now, if a muon can evade time and stretch time out for itself in order for it to not deteriorate on its way through our atmosphere till it gets to the surface of the Earth, you're telling me that this advanced society of other beings from another world haven't worked out how to travel through time themselves? What I'm saying is, if we did put out that message, say in another year's time, and lots of them, and it was intercepted, then they could come back before we even built the laser, knowing that we'd already sent the message. I'll tell you something. I'm going to answer a little thing. I was going to have a conversation with Scott, but I don't mind sharing it with all of you. I've had a couple of experiences in my life. I can't quite work out why that was, but I will tell you about one briefly. I'm standing in the garden with my dad, about a foot away from me, and we're looking at the sky and the clouds, and we're looking at something very far away, and it's shiny in the sky. And I said to my dad, I said, that's a balloon, one of these foil balloons filled with helium. A few seconds later, about 1 metre in diameter, big ball which is coloured like a pearl comes very, very slowly in front of us, about 10 feet away, if that. Then it came from round a tree, first of all, about 9 feet in the air, 10 feet away, weren't far away, we saw it, and then it went up over the roof and disappeared. It made no noise. It appeared not to have stopped in that duration of time, and it was probably lasted a couple of seconds, 3 seconds. And I just turned to my dad, I said, did you just see what I saw? He said, yeah. I said, what was it you saw? Because I knew exactly what I saw. I wanted to make sure he did see it. Well, it would have been hard not to, because it was like so close and on top of us. But get to the point. The point is, it had no control surfaces. Balls aren't aerodynamically designed to fly in the substance of wind. This had no noise, so obviously no visible signs of propulsion. It wasn't a balloon, because it was navigating around obstacles. So I can only say it's not something that possibly originates from this planet because of the level of technology. It was obviously showing some form of antigravitics. I don't know whether it was a superior evolved being, and eventually everything forms spheres. I don't know in the future whether after millions of years of evolution we will evolve to look like a sphere. And you might think that's a little bit crazy, but if you just look at the study of Darwinism, and I'm not agreeing with everything that we came from monkeys, but he did do some other good scientific work which shows that species have the ability to adapt to environments. And he done some studies on birds with different beaks, how their beaks had evolved to eat the food that was more widely available for that species of bird, like nuts. So it needed a big beak, strong beak that could break the nut and get the material out there or the food outside the nut. But we don't know if we evolve into a sphere later on down the road, and we don't know if we have already been successful with our laser communicator. But I will say this, I did have that experience with my father, and I'm glad I was with somebody else, because if it had been on my own, I would have always questioned this. Now, the story that I was going to get to with Scott, I promised him that I would tell him about this, because he said that he'd watched one of our videos that we put on there, and we was talking about the universal equation. It's what I've called it. I haven't seen many others in my lifetime demonstrate this. In fact, I've seen no one else other than me demonstrate it. And then perhaps this has travelled like a little ripple in the water on this world we live in, and it's got round, and there should be quite a few people now in the knowledge of this equation. And it's not rocket science. You don't have to use all these scientific notions and numbers and E equals mc squared and things like that to work out what it is. It's a unique equation, and he's asked the question, where did I come about it? And the answer is, all as I can remember is, let me first tell you, if you don't know what the universal equation is, it doesn't matter what number you put in there, you'll get one of two results, either a 9 or a 0. And you can go back in the videos and find the universal equation video, and just I demonstrate it more than once in more than a few videos. But the point is this: if you can reduce everything down into just two numbers, you've almost got a binary code. And we use binary today. It's ones and zeros. It's interesting that we was talking about this in yesterday's videos, the ones, but nevertheless, let's get on with it. So how did I come across that universal equation? I was going through a little bit of a unusual period in my life, and I was asking the question, we get up, we eat, we go to work, we come home, we eat, we go to sleep, and we might do a few other things in the midst of all that, but the majority of our life is very repetitive. And I was just thinking, what is it about life, and is there more to it than this? Because if not, then if you're very intelligent, well, you don't have to be very intelligent. It's going to be mundane from the point of starting life to the point of finishing life. It's going to be mundane if that's all we do. And one morning, I'm thinking about in fact, I was asleep. I know I was, and I got this equation come in my head. And I woke up that morning very early, and I wrote the equation down, the universal equation, and I just played with it a little bit. And then it dawned on me, if we can give a numerical value to a cube, a sphere, a cylindrical device, and then we can use other numbers like Fibonacci sequence to describe how plants are made. We've also got other beautiful equations like the golden ratio and pi and things like that. But if we can use a numeral value for like objects, then we put that into this universal equation, we can transmit we can refine everything in our universe, literally everything, down to a binary code. We just need to work out what the binary code is to understand how our universe then is created. So that's how I came about it. I've admitted this many times. I'm not a genius. That equation is well above me.
I've never come across that equation before, and for me to, stumble on that in the manner I did, I thought it was very strange. And at a time where I was asking the question, what is life all about? And I just wanted to share that with you. I just wanted you to know, first of all, that I'm not that intelligent to, design an equation like that. I believe it was put in my thoughts whilst I was sleeping, and when I woke up, I immediately, still in my underwear, wrote the equation down, and then only a couple of weeks later, I began to realise the importance of that equation. And if many more people did take a little bit of time out for themselves and just ponder what that equation means, they would know a lot more about their universe, and they would know whether there was a creator or not, or a prime creator, regardless of whatever name of God you want to give it. Yeah, because simply, if this universe goes about creating as it does in a conscious manner, because first of all, if it's using equations and binary code to create, then obviously it's got to be conscious. And if that's true, and it is, then surely that must be what prime creator is all about. So it answers the question for those some of you that have doubts, whether there is such a thing as a great creator. Well, there is, obviously, and the proof of it is an equation existing, like the universal equation. So I just wanted to share that with you, and it doesn't really matter whether this all gels with you. It's my experience, and I was going to share it with just Scott. I have shared it with a couple of other people, but I just wanted to put that out there. I do think that there's something else that we're all capable of being in touch with, absolutely. And a lot of people just simply write things off as coincidences or synchronicity, and I think there's a lot more going on than just that. I believe that there is such a thing as fate, and you can temporarily, I believe, change fate, but it's like an elastic band. If you're trying to change the future, all you're doing is stretching this elastic band. It never snaps. It will eventually come back. And what that means is you might evade not drinking your coffee this morning because you're going to say, I'm going to change fate, I'm not going to have this coffee. But wherever you was going to get from that coffee right now, I believe you're going to get from something else equally the same later on throughout the day. And if you're trying to change your future, then I believe equally you are set on a course, and you will be on that course later on, even if you try and avoid it. In my view, you're just stretching that bit of time momentarily, but you can't do it permanently. So there you go, guys. I just wanted to share that with you, guys. As you know, we're building the muon detectors. We were trying to find out how much radiation is inbound on our Earth. We're also tracking the magnetic north poles, and hopefully we're going to have some data very soon from one of our locations, hopefully from California. And when we get that, we'll put it up on the website. But a little bit off the subject today, but I hope you got something out of it. And as always, guys, if you want to support what we do at the Mavstar Observatory, there's a link down there. You can support us on PayPal or Patreon. It's entirely up to you. I'll say what I usually do. Guys, have an amazing week. I'll catch you up later. Bye for now.